Okay, so in this lesson, we're going to look at a special type of equation which is known as a modular equation. So modular equations, that's the title of this lesson. So before we go into modular equations, I would like to just explain the meaning of these modulars. Usually, when we are doing calculations in mathematics, or when we are even trying to calculate the absolute error or the percent error in chemistry, we come across a term where we write our variable, and then that variable is between two vertical lines. So these two vertical lines, these are what are known as a modulus. Then this modulus, it's a mathematical term. In science, this modulus is called an absolute value. That's why we'll find that when calculating the absolute error, we use these straight lines because absolute is the same as modulus. So when you hear modulus or you hear absolute value, it simply means whichever variable you're working with, you put it between two straight lines like that. Now, a question is, what do these straight lines mean? What does this absolute value imply? So an absolute value simply implies that we are only looking for a positive outcome or a positive solution. For example, if we get a negative number like -2 and we place it in a modulus like this, it simply means our answer is +2. Even if we get a positive value, for instance, we get +3, we write it between straight lines like that, meaning we want the modulus or the absolute value of +3. Here, the answer is still +3. So in short, the main purpose of a modulus is to just cancel the negative. And that is what a modulus means. A modulus means that the outcome is always positive. Now, when we start bringing this modulus into mathematical equations, the simplest equation that you can find can be written like this. The modular of x is equal to 3. Then you're asked to find x like that. So when you have a modular of x is equal to 3, when we get rid of these straight lines, we get rid of these absolute values, it simply means that value of x was either -3 or the same value of x is +3, like that. So a modulus will always give two answers when we get rid of these straight lines. Those two answers are either a negative outcome or a positive outcome. And that is the first and simplest type of modular equation that we can come across. Another scenario, we can find maybe modular of z is equal to 5. This simply implies that z is either equal to -5 or, let me write that down properly. So when we have modular of z is equal to 5, it implies that z is equal to -5 or z is equal to +5. So that is the implication of a modulus. Now, before we go any further, if you come across an equation like this, modular of x is equal to maybe -1, like that, and then you're asked to find x. When you are given a modulus and a negative outcome, such an equation is invalid. So you simply write invalid because this modulus is only supposed to produce a positive result. We can only have a negative result when we cancel these straight lines. So it is this x which can be positive or negative, not the outcome. So even if you have a complex modular equation, for instance, you are given x plus 3 in a modulus like that, then they tell you it's equal to -5. As long as the outcome of a modular equation is negative, then that equation is always invalid. So you keep this in mind because this is a very tricky question that is usually encountered in tests or in quizzes where we are given a modular equation with a negative outcome. So as long as the outcome that you've seen is negative, just keep in mind that that equation is invalid. But let's say instead of having a negative outcome, this modular x plus 3 is equal to +5. Like this, when we have a positive outcome, it means the equation is valid, and we can actually solve this equation to find the values of x. So in this case, the way you tackle this equation, you remove the modulus so that you just remain with x plus 3. So when we remove the modulus, then the outcome can be negative or the outcome can be positive. So when we have modular x plus 3 is equal to 5, it means x plus 3 is equal to -5, or x plus 3 is equal to +5. And in such a scenario, when we have these two equations, all we have to do is to solve for x in both cases. So when we pick the first case, we'll be able to know that our x will be -5, and then the +3 goes that side, it also becomes negative. So in this case, x is -5 minus 3. Therefore, x will be equal to -8. Or for this other scenario where we have x plus 3 is equal to 5, then it will simply mean x is equal to 5 minus 3, and therefore x is equal to 2. So we'll find that for every modular equation that we solve, we'll have two outcomes. The first outcome will be as a result of the modular equation with a negative solution. Then the second outcome will be as a result of the modular equation with a positive solution. So this is the first basic step that we must always follow when we are trying to solve a modular equation. First of all, we check the outcome. Is the outcome negative? If it's negative, it's invalid. If it's positive, then that equation is valid. And once we find that the equation is valid, we can break it down into two parts. One part with a negative outcome, the other part with a positive outcome. And then we solve those two equations separately. And then we're going to have two different values for our outcome, like that. So we'll just try out another example, then we'll go to the next part where we look at some complex modular equations. So the other example, we can have something like 2x plus 3 is equal to maybe, let's write a 7 there. So in solving for x in this modular function, we look at the outcome. We have seen that the outcome is positive. So this modular equation is valid. Once we confirm that the modular equation is valid, then we break it down. We remove the modular sign, then we can have a negative outcome, or we can have a positive outcome, like that. And once we have that scenario, we then solve our two equations separately. So the one with a negative outcome will have 2x plus 3 is equal to negative 7. So 2x, let me just write that properly. So this means 2x will be equal to negative 7 minus 3, like that. So 2x will be equal to minus 10. Then we divide by 2 on both sides. So in this case, x is equal to minus 5. That's our first solution for the modular equation with a negative outcome. Then we go to the modular equation for a positive outcome. Then when we go to that equation, we'll have something like this. We'll have 2x plus 3 is equal to 7. So in this case, our 2x will be 7 minus 3. So our 2x will be 4. Then we can divide by 2 on both sides. And in this case, our x is equal to 2. Therefore, the values of x are negative 5 or 2, like that. So these are simple modular equations. Then I'm going to write two equations down. You solve them, and then just solve them and send the solutions before you go to the next video for some complex modular equations. So we have modular x plus 1 is equal to negative 4, and we have modular 3x minus 2 is equal to, we can put maybe a 10 there. So you solve these two modular equations and then show me the solutions. Then we advance to some complex modular equations.